Hey guys, so hopefully you haven't forgotten the stuff that we were talking about in the last video. I don't know if you guys are going to be watching this video immediately after the other one because the scheduling might not work out the same way. But if you need a quick refresher, we're talking about the planets. We're going through each planet, how long its day is, how long its year is, and the tilt of the planet's axis, which affects how it perceives seasons, or how you would perceive seasons if you were on that planet. So we talked about the inner planets, and you can see that the day length, it doesn't really follow any pattern. Mercury and Venus are longer than Earth and Mars. There's no real pattern there. There's no real pattern to the axial tilt either. But you can see with the year length that it is getting progressively longer. Now with Jupiter, Saturn, Uranus, and Neptune, that pattern does continue, and we're actually later on in the month we're going to talk about why that is. There's actually a law of planetary motion. So we've got Newton's laws of motion, and then we've got Kepler's laws of planetary motion, and one of them dictates the length of a year. But we're going to get to that later. So right now we're going to continue with the next four planets, the first of which is Jupiter. And Jupiter, as you know, is the largest planet in the solar system. It's actually so big that it's about 10, some places say 11, but it's about 10 Earths across. So basically, if you had Jupiter up here, that's not a circle, but close enough. If you had Jupiter up here and you tried to draw Earths going all the way across, you would need 10 Earths just to go across the equator of Jupiter. Now Jupiter is actually a little bit squished, not quite as squished as I've drawn it here, but it's a lot bigger than Earth. So you would expect that its day length is significantly longer, but actually the reason that it's squished is because its day length is really short. It's rotating extremely fast. And it turns out that Jupiter completes an entire day, an entire rotation, in just 10 hours. So picture, Earth takes 24 hours, and then you take something that's 10 times bigger than Earth in terms of its radius, and it goes around in less than half the time. It completes a full rotation in less than half of that time. So a Jupiter day, a Jovian day, is only 10 hours, which is really fast. So it does lead to kind of like fast winds and stuff, and some big storms and such, like the Great Red Spot, which I believe we talked about in our presentations. If you've forgotten what the Great Red Spot is, it's basically a storm that's the size of like a couple of Earths. And it's basically like a giant hurricane, and it's red, and it's on the surface of Jupiter, or it's in Jupiter's atmosphere. And it's caused by, the really fast winds are caused by the planet's really, really fast rotation, causes it to kind of whip around really fast. So its day length is just 10 hours, but its year length, because now we're starting to get far off into the solar system, its year length is getting increasingly longer. So we've got like 3 months and more than half a year, and then a year and just shy of 2 years. But then we start to see that the year lengths get significantly longer. 1 year on Jupiter is equivalent to about 12 years on Earth. So what that means is Earth goes around the Sun 12 times, or about 12 times, in the time it takes for Jupiter to go around the Sun once. So, for example, that would mean that I am not even 2 years old yet on Jupiter. I'm a year and a half and a little bit. I guess like most adults that would only be like 3 or 4, not much older than probably 5. Your grandparents, in Jupiter years, are only 5, 6, 7 years old. So that's a bit weird to think about. And then axial tilt, Jupiter is similar to Mercury, or you could say similar to Venus. It's 3 degrees, but it is orbiting in the right direction. So Venus looks like that. Jupiter is just going the other way, like opposite to Venus. So it's going in the same direction as everybody else. So Jupiter is basically upright, but not quite. But yeah, it has an axial tilt of 3 degrees. Next planet, Saturn, is the second largest planet in the solar system. and it's similar to Jupiter in terms of its day length. So once again, it's a huge planet, but it rotates really, really quickly. And I believe it was the Cassini mission, which crashed into Saturn a couple of years ago on purpose, that actually figured out Saturn's rotation period. It wasn't known for sure before that, but it's similar to Jupiter. It's about 10.5 hours. Obviously, Saturn is known for its bright ring system, not its fast day length. So its day length is similar to Jupiter's, but its year length is, once again, we're getting much, much longer, right? We went from about 2 years here to about 12 years there. Now Saturn takes 30 Earth years to complete one orbit around the Sun. So what that means is, if I was counting my age in Saturn years, I have not had my first birthday yet. I'm 10 years away from it, in fact. So, 10 Earth years away from it, in fact. So the axial tilt of Saturn, it's again not that different from Earth and Mars. It's very different from Jupiter. And you can actually see this. When you look at pictures of Saturn, you always see, where's my eraser? You always see, you've got the planet Saturn, and then you've got its rings, which are on like this kind of lopsided angle relative to the planet. And so the reason for that is because of the axial tilt of the planet, which is about 27 degrees. So basically that means that if you put a pole there and a pole there, and then you measure the angle from like a vertical line, this angle right here, right inside there, that angle would measure to be 27 degrees on a protractor. Saturn obviously does have the largest and brightest ring system. Now those rings are so wide that they basically span the distance from Earth to the Moon, but they're so thin that if you stacked 5 Mr. Rickies on top of one another, that stack of 5 Mr. Rickies would be taller than the thickness of Saturn's rings. In some places. Saturn's rings are thicker in some places to like a kilometer or something, but in other places they're only about 30 feet thick, which is really quite thin for something that large and that far away. For us to be able to see it so clearly, even though it's just a few Mr. Rickies tall, that's quite thin. But they are really bright, and it has a lot to do with the reflectiveness of the materials that make up the ring. So the rings aren't these solid disks around Saturn. It's actually pieces of ice and debris and stuff that all reflect light, but there's so many of those chunks that it looks like a solid disk from where we are. So if you were in the Saturn system, you'd see this whole bunch of debris around the outside of the planet. But you'd have to get quite close to actually see the difference between solid rings and the actual debris. Now Saturn is made primarily of hydrogen and helium. And this is neat because hydrogen and helium are the lightest elements in the universe, the 2 lightest elements in the universe. And so that actually, the amount of hydrogen and helium and the lack of other stuff in Saturn means that it's so you could say light, but it's not that it's light. It's that it's less dense than water. It's the only planet in the solar system, in fact, that's less dense than water. So if you could take a big enough bathtub that had room to drop the planets into, every other planet, including tiny Mercury, would sink down to the bottom. I say tiny Mercury, but if you had something the size of a planet and you put it in a bathtub, you would expect it to sink. Saturn, even though it's gigantic, would float because of the hydrogen and helium content in the planet's atmosphere. So Saturn is the only planet that would not sink. So that's kind of cool. Saturn also has a lot of moons. Jupiter has more. Jupiter has, I believe, 79 confirmed moons. Saturn is somewhere in the 60s, I want to say. 62 or 67, something like that. But yeah, so that's Saturn. The next one is Uranus. The day length, it's actually not that important, and you're going to see why, but the day length on Uranus is 17 hours. So shorter than Earth, but if you remember from our diagram of the solar system, it's not that big, at least not compared to Jupiter and Saturn. So this is a more reasonable number. But its year length is actually really, really long. So it's twice as far, it's more than twice as far away from the Sun as compared to Saturn. So its year length is actually 84 Earth years, which means that my grandfather would have celebrated his first birthday not that long ago, if we were counting in Uranian years. Now, the reason the day length on Uranus is not so important is because its axial tilt is 98 degrees. Now, for those of you who've studied angles in math, which is hopefully all of you, you will know that a right angle is 90 degrees. So if we're saying straight up and down, this straight up and down right here is 0 degrees, then 90 degrees means that it's basically rolling on its side. And 98 is just a little bit more than that. So Uranus's axial tilt actually looks something like, and then it will be rotating this, something like this. So it's basically rolling on its side. So if you've got the Sun over here and Uranus over there, that's basically what it looks like. So even though it's rotating this way, it's not actually affecting where the Sun is in the sky for at least part of its orbit. So it might take 17 hours to do this, but this side of the planet is basically getting daylight for half of this time. So 42 years of daylight, while this side is stuck getting 42 years of darkness, of nighttime, basically. And so that's kind of the thing that sets Uranus apart from the other planets. So Jupiter has the Great Red Spot, Mars has, polar ice caps maybe, Saturn has its rings, Venus has its intense heat and atmospheric pressure, Mercury's got, I guess, it's quite dense. I don't know if I said that it's quite dense, but it's a very, very quick planet. It's the smallest planet. Every planet has some sort of claim to fame. Smallest, hottest, has life, whatever, going down. But Uranus's sort of claim to fame is that it essentially rotates, it rolls on its side, it rotates sideways. And the last planet, Neptune, it's similar to Uranus in terms of size. It's similar to Uranus in terms of day length, actually, as well, which is 16 hours. It's similar to Uranus in color. Neptune is blue, Uranus is more of a blue-green, but it's much, much paler. So if you put the two side by side, it's not that, they don't look that similar, but some people have been known to confuse them, that if you had a diagram and you just kind of color a ball, the color of Uranus and the color of Neptune, a lot of people get the two colors mixed up. One's blue, the other's more of a blue-green. Neptune, similar to Jupiter, Neptune has a big storm on its surface, which is maybe not quite the size of Earth, but it's a fairly large storm. It's called the Great Dark Spot, and Neptune actually has the fastest winds in the solar system. It's really, really fast winds there. And the year length of Neptune, this is ridiculously long. So Neptune takes 164 years to go around its axis, to go around the Sun once. And its axial tilt is similar to Earth and Mars and Saturn. It's 28 degrees. So, similar to Saturn. All four of these planets down here, remember, they have rings, and those rings do orbit in relation to this axial tilt. So Uranus's ring system does actually look like that around the planet. But Uranus and Neptune's rings are so dark, so dim, that it's really difficult to see. But yeah, so that's it for looking at the planets, the day length, the year length. If you notice, the year length does get longer and longer. There's no real correlation with the other two, but we are going to examine the year lengths later down the road, after your exam, if there's time to spare. That's when we'll talk about the year length. So once again, if you guys have any questions, leave a comment down below, or reach out to me via email, or whatever. One of you, a couple of you have reached out to me on Instagram. Find a way to get in touch with me if you have any questions. Otherwise, I will see you guys in our next lesson.